Hi guys, welcome to Logarithms 5. This is the final session in the topic of logarithms. In the last 4 classes, we have seen the properties of logarithms, we have seen the definition of logarithms, and in the last 2 videos, we have covered a bunch of problems using logarithms. Now, we're going to look at a very interesting aspect called the inequalities of logarithms. Now, inequalities is a normal topic. Why is it any different in logarithms? It is not actually. However, you will realize when we solve few questions and we look at some examples in today's video that the inequalities in logarithms can be really tricky because there are many conditions you have to take care of. That is the reason why we are covering separately inequalities for logarithms. Otherwise, it's the same. I mean, at the end of the day, inequality basics will not change. Your concepts of inequalities remain the same. However, when inequalities are applied into logarithms, you will come across so many situations where you can make an error. And today's class is all about exploring why those errors happen and, more importantly, how not to get those errors, how to escape those errors, right? So that's about me. I'm quickly skipping this part. Right, so let's first understand the basic logarithmic inequalities. Now, there are 2 cases that we're going to look at. The base, which is greater than 1, is the first case, and the base is between 0 to 1 is the second case. When the base is greater than 1 and you have 2 numbers, x and y, where x is greater than y, then log of x to the base a will be greater than log of y to the base a. This is evident from the graph. If you remember the graph of logarithm, this is how the graph of logarithm is. When base a, so this is log x to the base a, where your a is greater than 1. Correct? And this point is your x equal to 1. Now, if I'm taking this point as x1 and I'm taking this point as x2, very clearly the output at x2 will be greater than the output at x1. Because x2 is greater than x1, very clearly log x2 will be greater than log x1 for the same base, right? So this is what the first statement says. It's obvious if you look at the graph, but I'm putting this across in the mathematical form. If you look at the graph where the base is between 0 to 1, then let me draw the graph first. I don't know how many of you remember this. I hope all of you remember. My graphs are not perfect. But this is how the graph will look like. Okay, I will draw the graph perfectly. Right, this is how the graph will look like. So this is the graph of log x to the base a, where a belongs to 0, 1. A belongs to 0, 1, and x equal to 1 is this point. Now you'll notice that when the graph is between 0 to a, if you take any 2 points, let's say you take this point. This is point x1 and this is point x2. Now when x1 is or x2, x1 is less than x2 or x2 is greater than x1, then log of x2 and log of x1, when you compare, the sign will be different because you can see at x2 my graph is at a lower level and at x1 my graph is at a higher level. Even in this side you can notice that if this is my x1 and this is my x2, now when x2 is greater than x1, that's how it is. Once again the graph log of x2, this is negative, remember this is negative. Larger negative means smaller in value, right? So smaller negative, this is again negative, means higher in value. So when your graph is between 0, or rather your base is between 0 to 1, log of x will be less than log of y if x is greater than y. This is the fundamental basis on which we are going to use, or we are going to solve all our questions today. So you have to remember this. What happens when your base is greater than 1? What happens when your base is less between 0 to 1? The other few things that you also have to keep in mind is when you write in general log x base a, it is understood that a is not equal to 1. It is understood that x is greater than 0. You have to make sure that your answers also comply to this. You have to make sure that your answer also comply to these basically two conditions. So let us see how do we implement this in questions, and I'm going to categorize questions into different types. The first type of question of inequalities come when the bases for comparison are same and they are actually greater than 1. Simplest of the form. So I have a logarithm on the left hand side, I have a logarithm on the right hand side, and you can see that the bases are same and clearly the bases are greater than 1. This is the simplest of the comparison. Now we know when two bases are there, log x1 base a is greater than log x2 base a, and if we know that a is greater than 1, this happens when x1 is greater than x2. That's the first condition. We will use it as it is. So this term should be greater than 2x plus 7. So you can straight away write 3x minus 2 greater than 2x plus 7, and you'll get your answer x is greater than 9. But before you mention x is greater than 9, also make sure that your 2x plus 7 should be greater than 0 and your 3x minus 2 should be greater than 0. And because if they are not greater than 0, then left hand side or right hand side might not be defined at all. So from the first one you get x is greater than minus 7 by 2 and x is greater than 2 by 3. So your final answer should be x is greater than 9 and so the intersection of all these three. Clearly the intersection of all these three. If you are new to inequalities or if you're not very comfortable, write down the points. Minus 7 by 2, you have 2 by 3 and 9. X is greater than 2 by 3 means this entire region. Correct? X is greater than minus 7 by 2 means this entire region. And x is greater than 9. X is greater than 9 means this entire region. So what is common to all three? You can see the common part is this. So clearly the answer should be x is greater than 9. So in this question, these two conditions are not helping you. They are giving you the same answer. It might not be like that in every question. So do not forget to check for these 2 points. Right? Moving on. Next, what happens? The case when the logarithm is a little bit more complicated now. So you have call this as a and call this as b. So you have log of a base 5 is greater than log of b base 5. Now you know this is only possible when a is greater than b, which means straight away you can write log of 5x plus 2 to the base 3 is greater than log of 2x minus 1 to the base 3. Now in this comparison, you can notice that 3 again is the base which is greater than 1, which means straight away you can write 5x plus 2 is greater than 2x minus 1, or this gives you 3x greater than minus 3 or x greater than minus 1. This is the answer that you get. But however, before writing or finalizing your answer, also make sure that your logarithms are defined. So when is this log a to the base 5 defined? When your a is greater than 0. If a is greater than 0, it means log of 5x plus 2 to the base 3 should be greater than 0. Right? When is this greater than 0? When 5x plus 2 is greater than 1. Or this gives you x is greater than minus 1 by 5. X is greater than minus 1 by 5. Similarly, the right hand side is defined when the right hand side is defined, that is log b base 5. This is defined when b is greater than 0. Obviously, b cannot be less than 0. So this gives you log 2x minus 1 to the base 3 greater than 0, because that's what we've taken as b. So this gives you 2x minus 1 greater than 1, or x is greater than 1. So you want a common answer for this and x greater than 1 and your x greater than minus 1. You can draw your number line and figure out, but if you are a bit fast, you can realize that the common area is only x greater than 1. If you don't want to draw the number line, you can draw it here quickly and see what happens. Just drawing it once more. So you have a minus 1, you have a minus 1 by 5, and you have a 1. So x greater than 1 This is the range. This is the area. X greater than minus 1 by 5. Minus 1 by 5, I will draw in black. This is my answer completely. And x is greater than minus 1. X is greater than minus 1 gives me this part, this entire thing. So red, black and green, all three is common for x greater than 1. So the final answer becomes x is greater than 1. Here, if you notice, these conditions made a difference. So your actual answer that you got, x greater than minus 1, is actually no more your answer. When you couple that with the extra conditions for the validity of logarithms, because the log has to be defined, so there are extra conditions coming from there, you will realize that my final answer is way different from what you've got initially. And this is the reason why inequalities in logarithms can become tricky, because if you forget to check for the validity of your original logarithm, then you will get an answer which is incorrect. Okay, let's move on to the next question and see what happens here. Right, so now we are looking at a simple condition where the base is less than 1. Now we know that we have seen that when log x1 to the base a is greater than log x2 to the base a, and we know that a is less than 1 and greater than 0, in this condition, clearly x1 will be less than x2. We have seen this in the first slide, right? So if you apply this straight away, I'll get 3x minus 2 is actually less than 2x plus 7. Or this gives me x is less than 9. This gives me x is less than 9. But please don't say this is your answer. You have to make sure that left hand side is valid. Left hand side is only valid when 3x minus 2 is greater than 0 or x is greater than 2 by 3. Right? And right hand side is valid when 2x plus 7 is greater than 0 or x is greater than minus 7 by 2. So now you're looking at minus 7 by 2 is here, 2 by 3 is here, and 9 is here. So first x is less than 9. X is less than 9. This is my region. X is greater than 2 by 3. Greater than 2 by 3. This is my region. X is greater than minus 7 by 2. Minus 7 by 2. This is my region. Now you will notice that my common area is only this. So my final answer becomes x belongs to 2 by 3 comma 9. This is my answer. So you can see very clearly that what you got is different from what the final answer is. So once again, the importance of logarithm being defined and the condition that comes from there plays a role in this. Right? Well, that's about the same base. We have a similar question here. I will very quickly take you through this. So here, clearly, this is A and this is B. Because the base is less than 1, your A is now supposed to be less than B, which means log 5x plus 2 base 1 by 3 is less than log 2x minus 1 to the base 1 by 3. Now, once again, when you're comparing, this is your K1, this is your K2. Because the bases are less than 1, your K1 is supposed to be opposite in sign to this. So if this is less than, then this will become greater than. So you will have 5x plus 2 greater than 2x minus 1, and this gives you 3x greater than minus 3 or x greater than minus 1. Your job is not done. You will have to make sure that 5x plus 2 log of 5x plus 2 to the base 1 by 3 is greater than 0, because your left hand side has to be defined, which means 5x plus 2 greater than 1 or x is greater than minus 1 by 5. Similarly, right hand side has to be defined, which means log of 2x minus 1 to the base 1 by 3 is greater than 0. So 2x minus 1 greater than 1 or x greater than 1. So you need an answer which is satisfying all these three together. So you have minus 1, minus 1 by 5 and 1. So x greater than 1, this is the region, x greater than 1. Now if I mark x greater than minus 1 by 5, this is my region, minus 1 by 5. And when I mark x is greater than minus 1, this region, that will become like this. So the common for all of them is your x greater than 1, and that is your final answer. Okay, so you're looking at the inequalities where multiple conditions are involved. That's where you have to be careful about. All right, so that's about same base. Now we'll look at the second type of questions where the bases are similar, not exactly same. Now what happens in this case? You can see the base here is 4, the base here is 2. So you can't directly compare these two. So the logic for these kind of questions is somehow try to make the bases same, without which you cannot solve. So if I try to make the bases same, I will get, if I just change the color, yeah, you will get log 2x plus 3 to the base 2 greater than, I will write half log 3x plus 7 to the base 2. So this I can write it as log 2 log 2x plus 3 to the base 2 greater than log 3x plus 7 to the base 2. This can become log 2x plus 3 whole square to the base 2 greater than log 3x plus 7 to the base 2. Now the bases are same and clearly 2 is greater than 1. I can straight away write 2x plus 3 whole square should be greater than 3x plus 7. So if you expand it, I'll get 4x square plus 3 to the 6, 6 to the 12, 12 minus 3 is 9. So plus 9x plus 3 3 is a 9 minus 7, 2 greater than 0. Right, so this is a quadratic expression, inequality. I can factorize this. How will I factorize this? I can factorize this as 4x square plus 8x plus x plus 2 greater than 0. And this becomes 4x when I take out common, x plus 2 plus 1, x plus 2 greater than 0. And this becomes 4x plus 1 into x plus 2 greater than 0. So if you remember the basics of inequalities, how do you get the answer to this? You will mark the 2 points. The points are minus 2 and minus 1 by 4. So greater than means tick, cross and tick. Those of you who are unaware of this, I recommend that you take a look at the basics of inequalities. Okay, so your x is supposed to be belonging to minus infinity comma minus 2 union minus 1 by 4 comma 0. But before you do this, you will also have to check for the validity of your left hand side logarithm and the right hand side logarithm, which means 2x plus 3 should be greater than 0, because that's how the logarithm is defined, which gives you x is greater than minus 3 by 2. And 3x plus 7 right hand side should also be greater than 0, which gives you x is greater than minus 7 by 3. So you want this x and intersection of x belonging to minus 3 by 2 comma infinity and intersection of x belonging to minus 7 by 3 comma infinity. You want the common area to these three parts. You want the common area to these three parts. So if you are quick at analyzing, looking at it, you'll get your answer. Otherwise, no problem. Draw your number line and that will help you out. So I'm just making a little bit of space over here. So if you want to draw your number line and write down the parts that are mentioned over here. So this is your number line. So you have to very carefully put down the parts. So minus 7 by 3 will come here. Minus 7 by 3 is 2, 1 by 3. Then you will have minus 2. Then you will have minus 1.5. That is minus 3 by 2. Then you will have minus 1 by 4. Now, first write down the initial x and I'll mark it in black. So minus 2 and minus infinity, this, and 1 by 4, negative 1 by 4 and positive infinity. The next x, I'm going to write it in red, this x. So minus 3 by 2 to infinity. So that is this entire region. And the third part, I'm going to write it in green, minus 7 by 3 to infinity. Now you can see where is your black, green and red, all three intersecting. It is intersecting only in this region, which tells you that x is greater than minus 1 by 4. This should be your only final answer. X is greater than minus 1 by 4. You can also write this as x belongs to minus 1 by 4 comma infinity. Right? So this is how you need to solve your inequalities. Let's take a few more examples for you to understand. Same logic. Now here, sorry, not same logic, it's a separate case. Now in this case, so previously we have seen comparable bases or the bases being same. Now we are going to look at what happens when the bases are different. Again, here if you notice, the numbers to be compared are same. So I can write this as, basically write this as log 2x plus 3 to the base 10. I'll convert it to base 10 by log 5 to the base 10. Greater than log 2x plus 3 to the base 10 by log 7 to the base 10. Now, I know log 5 to the base 10. What will happen to this? This will be greater than 1. So I can take it to the right hand side. So log of 2x plus 3 to the base 10. Please don't cancel this like this. I'll tell you why you should not cancel it. Is greater than log 5 to the base 10 divided by log 7 to the base 10 into log 2x plus 3 to the base 10. Now, if you call this log 2x plus 3 as k, I get it as k greater than log 5 and to the base log 7 into k. Now, what is log 5 to the base 7? Log 5 to the base 7. Clearly, if you look at the logarithmic graph, the graph, if logarithm, is like this. This is your x equal to 1. Okay. If I want log x to the base 7, now when x equal to 7, my y will also become equal to 1. When x equal to 7, because what is log 7 base 7? Log 7 to the base 7 is 1. So the point you need to understand is between 0 to 7, between this region, your answer is 0 to 1. So the answer is lying between 0 to 1. So when x is between 1 to 7, your log x to the base 7 is between 1 and 0. So basically you're talking about this number. This is a fraction. This is a 0 point something. So clearly a k is greater than 0 point something into k. This is clearly possible, and this is true only for positive numbers. Only for positive numbers. Remember guys, for negative numbers it's the reverse. If I say, for example, if you take minus 2 is greater than let's say 0.6 into minus 2. Is this true or false? You will notice that this is false. This is false. Right? But which means if you take k greater than 0.6 as an example into k, this is true only for positive numbers, which means k has to be positive. Now the reason why I asked you not to cancel this log 2x plus 3 and log 2x plus 3 is because you do not know the sign of it. In inequalities, before you cancel something, you have to be careful about the sign. If you're cancelling out negative terms, then the in between greater than symbol will reverse. That is the reason why we did not cancel. Now we established that k is positive. Now we established that k is positive, which means your log 2x plus 3 to the base 10 should be positive, should be greater than 0, or 2x plus 3 should be greater than 1, or this gives you x is greater than minus 1. X should be greater than minus 1, right? So, and then this, your job is not done. Please make sure that your logarithm is defined also, which means if you're going to make sure that your logarithm is defined, what are you supposed to do? You're supposed to check left hand side and right hand side. Basically, because it is 2x plus 3, you have to make sure that 2x plus 3 is greater than 0, or x is greater than minus 3 by 2. So you want a common answer for minus 3 by 2 and minus 1. And clearly the intersection region becomes minus 1 itself. So sorry, yeah, minus 1. So this is your minus 1. Minus 3 by 2 comes first, then this is your minus 1. So x is greater than minus 3 by 2 is this region. X is greater than minus 1 is this region, right? sorry, minus 1 is here. So your common area is x greater than minus 1. So this itself becomes your answer. The whole idea for this question is separate when the bases are not same and they're not even similar, you can't convert one base into the other, take them out. Bring the bases to one side and form a fraction like this. Now analyze the fraction, what happens? Is it greater than 1? Is it less than 1? And there's a particular case where the 2x plus 3 this number and the 2x plus 3 this number are same. We will also see when things are not same. Let's take 1 or 2 examples and see what happens when things are not same. Let's look at the next question. So here, this is a quadratic expression. Very clearly, we'll start by saying this is x. So this is x square. So you will get x square plus x minus 6 is greater than 0. So you can simplify this as x plus 3 into x minus 2 is greater than 0. So this gives you x minus 3 and 2. So this is your region. Okay, so this is your region. So x belongs to 2 comma, so now remember x belongs to 2 comma or rather, first I should write the negative part. So minus infinity to minus 3 union 2 comma infinity. But remember your x is actually log a, which means log a to the base 5 belongs to minus infinity comma minus 3 union 2 comma infinity, which means a belongs to 5 to the power of minus infinity comma 5 to the power of minus 3, because I'm taking out the logarithm, union 5 square comma 5 to the power of infinity. This gives you a belongs to, now 5 to the power of minus infinity means 1 by 5 to the power of infinity. You have to be very careful in these conversions, by 1 by 125 union 25 comma infinity, because 5 to the power of infinity is infinity itself. And this gives you a belongs to, now remember 5 to the power of infinity is basically infinite. So 1 divided by infinite is approaching or will be 0. So 1 by 125 union 25 comma infinity. This is your answer. This is your answer. Now you have to again check when is a defined, log a defined. This is defined when a is greater than 0. So clearly you can see that all the answer that you got is anyway greater than 0. So your final answer is this. So here the learning is this conversion from logarithm to getting the value of a. It's an interesting small piece of information. Right, so let's look at the next question that we have. Right. So guys, this is the last question. So find the number of positive integral solutions of x in this particular inequality. So the first part of manipulation should be very straightforward for you. You have 2 log x base 4 plus 2 log 4 base x less than 5. I'm writing the 16 as 4 square. Then what do I get from here? I will get, or if I convert this, if I call this as a, I get this as 2a plus 2 by a less than 5. I took the logarithm to the denominator, because when I take the, I can use the inverse law of logarithm, right? So then this becomes 2a square plus 2 less than 5a. Now remember, I'm able to take this a to the right hand side after LCM, because I am only looking at positive integral solutions of x. So if x is a positive integer, it will always, the log x base 4, that is your a, will definitely be positive, because log of x to the base 4, as long as x is an integer and positive, which means it is greater than 1, it will definitely be positive. So I know for sure that my a is positive, so I can take a to the right hand side without changing the sign. You have to be very careful why I'm able to take this a to the right hand side without any worry. Simply because I know for sure that a is positive. Otherwise, I have to create two cases. What happens when a is positive? What happens when a is negative? And in each case, the sign, this sign particularly, will change. Right now, we don't have to do that. So this gives me 2a square minus 5a plus 2 less than 0. And this gives me 2a square minus 4a minus a plus 2 less than 0. And if I simplify this further, I'll get 2a into a minus 2 minus 1 common a minus 2 is less than 0, which gives me 2a minus 1 into a minus 2 is less than 0. So if you plot this, you will be getting half and 2. So this is cross, tick and cross. This is how you will be getting your final a value as, which means a belongs to 1 by 2 comma 2. But what is your a? Your a is log x, correct? So it means log x to the base 4 belongs to 1 by 2 comma 2. And this gives you x belongs to 4 to the power of 1 by 2 comma 4 square. So x belongs to root of 4 is not, sorry, it's not a square bracket, it's an open bracket, 2 comma 16. So how many integers are there between 2 to 16? So you have all integers 3 to 15 to be counted. 3 to 15, all of them have to be counted. Remember, it's a open bracket, right? Open bracket means 2 and 16 are not included. So 3 to 15, this is 13 integers. This is 13 integers. So you have, that's basically your answer. There are 13 integers which fit into this inequality, right? So guys, with this we will end our session on logarithms. We have done a lot of work on logarithms. I hope you enjoyed the sessions. The one thing to be kept in mind in logarithms is you need to be very careful, especially in the inequalities part of logarithms, right? Anyway, we have discussed about the laws and formulae of logarithms. If you do not know the formulae of logarithms, the chapter is almost impossible for you, right? See you friends in the next video of mine.